engineering is considered as a people-serving profession. I will not read this one because of the time restraints. And this is a contribution by civil engineering. You probably would have heard about this gentleman called Brunel. And the Brunel Bridge was designed. It's a very tall bridge, and there is a huge gap between the water level and the bridge, very large span. And this man, Brunel, and is a bridge builder in the 19th century, and he was recognized second only to Sir Winston Churchill, the great Prime Minister of the United Kingdom, considered as one of the greatest engineers in the UK at that time. And this is in Sri Lanka. Those of you who have heard about Dr. Kulasinghe, right, and one of the greatest engineers who actually died a couple of years ago, who was the chairman of the CECB, he pioneered some of these shells structured in Sri Lanka. This is the planetarium that you have. This is Kalutara Bodhya, and that is the harbour structure that you will see very close by. If you go out of the hotel, you can see this structure as well. And these water tanks and all that. That's one of the greatest civil engineers that we produced in our country, who invented a lot of things. Right, so civil engineers make the difference, and the American Society of Civil Engineers say that we build the quality of life of people, okay, through their developments of infrastructure and other aspects. Okay, any questions that you would like to ask? Questions at the end if you have, right? The generic questions. Right, let me explain a bit on the material science and engineering aspect as well, and where we highlight things on the metals, ceramics, and polymers. Right? Now, when you consider metals, you have steel, copper, aluminium, and high-performance metals. So you have alloys, combining of several metals, you have high-performance metals. Ceramics, you have traditional ceramics, electronic ceramics, bioceramics, and engineering ceramics. Polymers, you have household, engineering items, rubber products, and latex. And nutrients in material science and engineering includes smart materials and structures. When you say smart, you design new materials which will have tremendously high properties that you normally don't have in a natural material. You combine materials, you have unique properties so that you can make use of that to achieve various engineering objectives. Biomaterials, nanostructures, high-performance composite. And if you specialized on material science, you have these kind of things that you develop the capacitors and piezoelectric sound that you normally have. There you have, it's kind of a crystal where you introduce a voltage to one end and the vibration at the other end, or vibration in one end and generate a voltage at the other end. These are used in your automobiles, that you have various beep sounds, that you have warning sounds. These are the things that you have. Thermal resistors. Now these thermistors, these are basically with the thermal temperature they become activated, and then the sensors that you all know. Right. The materials engineering also contributes so much in the biomedical aspects as well, that if you break your items in your body, legs, hands, or whatever it is, we have engineering solutions for those items. So it used to be in 1970, it was just, you can see, about 1,000 operations per year in the world about implants of various gadgets to your body. Now you have 250,000 operations per year, the artificial components that you insert in your body when you break things in your body, right? So where materials have to be designed to coexist with the body, right? Now these are the applications of materials engineering, the properties of specific kinds of materials. These are the aeroplanes, but in addition to that we have all the rockets which go to the moon, where we talked about all the high performance ceramics, and to cut off the excessive and tremendous heat that you generate, and you provide the safety to your crafts and things like that. So these are all the developments of the materials, properties that you consider. Right, your career opportunities in the material science and engineering, you will have, I don't know whether it is clear to you. Can you read? No? I think these lights are very problematic. Do you think that the video can capture without lights a bit? Yeah, but I don't know whether you can video me. Difficult, right? You have one light on maybe. One light? Okay. Right, where you have aluminium industries, steel industries, electrical cable components, Kalani cable, foundries, and things like that. In the ceramic area, you have all Dhaka porcelain, Lanka volatiles, Royal Ceramics, Ceylon glass, cement corporations, and Lanka tiles, Royal Firmwood, and all that kind of things. These are the places where you can seek a career as a materials engineer. The polymers aspects, you have Felix Plastics, Richard P. Reser's, DSI, St. Anthony's, Multimolds, AMW, Associated Motorways, Telebroke, Star Packaging, all these areas that you can seek your employment, right? And also research institutes as well. Okay. Right, any questions on the materials engineering aspects? These are all specific disciplines about engineering, right? Depending on your likeness, you can specialize. You can have a foundation course of engineering, which is normally common to any engineering discipline, and then you diversify into various areas depending on your likeness. Okay? Now, this is mechanical engineering. That you already know. There are lots of production taking place as well through mechanical engineering. These are some of the applications about the mechanical engineering. Basically, very briefly, you will have subjects like mechatronics, where mechanical and electronics are combined together. Subjects like mechatronics, where mechanical engineering or mechanical parts are combined with electronics. Now with the developments, you can see that there is nothing called pure mechanical, nothing called pure electrical. So in the applications, you need to combine these things. So you teach subjects like mechatronics, automation, and robotics that you are very fond of. Lots of teenagers are very fond of these kind of robotics and automation aspects. Things are automated very much, not so much in manual things. You need to automate to have the competitive advantage. If you use manual labor quite a lot, manual labor may be okay for developing countries where you have cheap labor, and Sri Lanka is no longer considered as a cheap labor country. And therefore, if you don't develop these concepts, we become completely non-competitive. And even developing countries with automation and things like that without much manual labor, their products may be cheaper than our products. So you need to specialize on the automation and robotics, energy, technology and environment, marine engineering and naval architecture, automobile engineering, all the developments that are taking place in the mechanical engineering arena. Right. So these are some of the things that we do, like computer-aided design of various, mechanical components. And this is an impeller where you have the computer analysis of the stresses and designing to find out, although you see that it is very simple things to happen. When you design a component, you need to really analyze the stresses building in each of the components so that we come out with a design which does not fail, right? You fly in the aircraft, you consider an engine in an aircraft, what happens if the engine stops, right? It has to be 100% reliable. So you need to do lots of testing and analysis, and the engineers are responsible for these aspects. Computer-aided manufacturing, where our computer is used to assist the manufacturing processes so that you have the precision, the absolute precision that you need in all these precision-related equipment and gadgets. Refrigeration and air conditioning is an area which specialized in the mechanical engineering. And the mechatronics I just mentioned, this is a lab that we have at Moratuo highlighting on mechatronics aspects. Thermodynamics and fluid mechanics. Subject areas where you consider, when you say thermodynamics and fluid mechanics, we use various kinds of liquids and fluids in mechanical engineering operations like hydraulics. Okay, you have hydraulics related equipment, very powerful. You probably would have seen hydraulic equipment used to break very heavy things like concrete, hydraulics. Okay, so those are all the designs related to mechanical engineering. And at Moratuwa we do several inventions. You have these inventions which include, things like the detection of explosives, bombs, demining robots that we have designed. And those who would like to pursue in this kind of research and development can certainly do these kind of experimentations, try to combine knowledge areas in various aspects, where the electronics together with various other sensoring equipment, materials, mechanical to have navigation, and electronics to have camera, messengers, and communication. So put together all these disciplines, you can have these application gadgets to suit Sri Lankan conditions and also other conditions as well. Right. These are some of the things that you design: underwater crafts, biomass gasifier to produce biomass. Right. Employment in the mechanical engineering disciplines, you have design and manufacture. Places like here, Leeds, Jinasena, Lodestar, where you come out with tire production, power and energy sector, CB, Lanka Transformers, oil, gas, Ceylon Petroleum. Then you have textile and clothing. You have world famous institutions like MS Holdings, Hydromony, food and beverages, John Kears, Nestle, Ceylon Biscuits, consumer products, CAD/CAM, computer design and manufacturing, research and development, and also in the IT and even banking sector as well. Okay, many more. Right, that is mechanical. Then you have other aspects like this one is earth resources engineering. So as the name implies, we specialized in the resources in the earth. Right, those who would like to investigate those and seek a career. Mining and minerals, you go underground, right? Minings and minerals, where you have explorations for gold, platinum, iron, coal. You specialize with knowledge areas like remote sensing and geographic information systems to detect before you do explorations to find out their existence. Ocean resources engineering, what happened in the bottom of the ocean and to harness those. Gem and jewelry aspects, geo-environmental engineering, oil exploration, that is coming up as a very important aspect in Sri Lanka as well, after identifying that we have some oil in Sri Lanka. Okay, so in the earth resources engineering, we specialize these aspects. Depending on where you want to specialize, you can decide on a career path in these areas. Textile and apparel technology or engineering. And in Sri Lanka, this is extremely important because we know that it is the #1 manufacturing industry in Sri Lanka. It is the main source of foreign income to Sri Lanka, as you know. And in 2009, we earned $3,150 million as a foreign earnings through this industry. And it contributes for about 50% of the export revenue and generates about 350,000 direct and about 1.2 million indirect employment. So this is a very popular industry in Sri Lanka as well, where engineers can contribute tremendously. Right. Then we move on to the electronics and telecommunication engineering that most of you would like to also. This is the highest demanding disciplines at Moratuwa University also, right? This one, electronics, is a rapidly growing industry throughout the world. And the industry contributes more than $1 trillion worldwide, $1 trillion. And value addition, if you are working in the raw material side, like silicon chips and things like that, the value addition is over 45%. Okay? If you work in a components, we don't have resources to do this one. It's very expensive. We need high investment. If you do component manufacturing, value addition over 25%. If you do final product assembly, value addition is about 10%, right? And this provides some statistics. IT equipment production, $1.6 trillion. Electronic components production, $850 billion. Devices, $450 billion. Semiconductor devices, $248 billion. Some statistics for you to get an idea. Right, but if you consider Sri Lanka, electronics exports is a very, very small percentage in the world. Sri Lanka electronics industry is not really developed. We need lots of electronics engineers to develop Sri Lanka because it's a highly value-added industry. If you have good electronics engineers and to develop and contribute in product things